Folks, I wanted to take a look at randomization on the Arduino really quickly because a few of you were running into this kind of weird glitch when using the random function. So to make a random number, we say random, and then we can give it, if we give it, we can give it a max. So it will give us this, for instance, would give us a random number between 0 and 10. We can give it a minimum, so if we want a number between 4 and 10, we could do that too, etc. So if I have random 0 to 10, that's not really necessary, but it does make it easy to read. Now, all programming languages are a little bit different when it comes to randomization in terms of how this works and what function they're using to generate the random values. Computers generate what we call pseudo-random values, and that they're not really truly random, but kind of quasi-random. And for the Arduino, the random function is going to return an integer that includes the bottom of the range, but excludes the top of the range. So when I say random 0 to 10, it's going to give me back 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, but never 10, okay? And if I go look at the reference for the random, we can see those parameters here, right? So the upper bound is excluded from the range. Okay. And so if I have code like this, I've got int r initiating to 20 just for clarity. And then in my setup, I'm resetting r to this random number, 0 to 10. And then in my loop, I'm printing it. And I'm getting 3. Now this value shouldn't ever change because I'm only doing the randomization initially. Like if I wanted to get a random LED number, for instance, when I start up, and then keep that consistent. Now when I hit the reset button though, I'm still getting 3. And in this case is where I would think like, oh, maybe it should change because every time it starts, it's gonna, pick a new value and then print it repeatedly. But no matter what I do, I'm always getting 3. And yours might be 2 or 5 or something else, but you're always getting the same number. So that has to do with the seed of that pseudo-random number generation. So the seed is like the starting value that it derives the rest of the values from, and we can set that in code. So we can say random seed and give it a value to change the initial okay, and now we've got 2, and I hit reset. We get 2 again. So that changes it, but it doesn't change it. And that makes sense because we're giving it the same, again, starting seed each time we run this too. So in one sense, this is nice because if we're trying to debug something, we can rule out randomization by giving it a set seed so that every time it runs, we're getting the same sequence of random values. But at the other hand, if we're trying to generate random values, it's not that great. So for the Arduino, how we deal with this, so computers often pull the seed from the clock, the computer clock or the system clock. The Arduino doesn't have a system clock, so it can't pull from that. So that's why randomization on desktop computers works a little bit easier than on the microprocessor because it doesn't have a clock to derive the seed from. So instead, we can't say random seed, random number because that's like circuitous, right? So we want to give it a kind of noisy value to generate the seed from. So instead of giving it a constant, I'm going to say analog read A1. So if I don't have anything hooked up to A1, it's just going to be kind of floating around in the environment, and I should get a weird value from that. let me try it. Okay, so now we've got 4, and I hit reset. We got 9, reset, 4, so you can see I'm getting some repeats, but I'm also getting a much wider range of values now for my singular random number than I was before whenever I reset this. So if I had the random happening more frequently in the loop, this would be much less noticeable. But in those cases where you want to just pick some random numbers initially, using analog read to set your seed is one way to deal with that.